welcome to our channel SKI Class Academy Learn to Rise. In our last video, we have seen about the concepts that are needed for designing a neural network. In continuation with that, today we will see about designing a simple neural network for a simple real-time problem. At the end of the session, we can understand about neural learning and the change for weight or cost in a network. So we will continue our lecture from the last lecture slide. Learning a complex behavior it is, so can be simplified for the time being as the incremental change in weight between the connected neurons in a neural network through time. In order to train our bunny, we have to repeat the process. The graph for the first three trials and the initial state would look like this. Please note that the weights for the tone go up after each trial, given in red color in the diagram. This amount is arbitrary at this point, that is choosing 0.30, but it could be anything, even a negative number. Even after the third trial, we have the same behavior from the bunny, but after the fourth trial, something new and amazing happens, that is a new behavior. We have removed the air puff and yet the bunny still blinks after hearing the tone. The explanation to this new behavior can be found in our final graph. So now we have trained our bunny to recognize a tone and to blink. We now leave the biological world of brains and bunnies, and we will adapt some of what we have learned to make an artificial neural network. The first thing that we will trying to do is to define a simple problem. Let's say there is a four button machine that we have that gives you food if you press the right button, and the objective will be to learn which button provides the foods. So let's see all the possible outcomes including the solution. In order to create a neural network in code, what we need first is we need a model or graph that we can match it with. So here is one such arrangement suited for our current problem that loosely emulates its biological counterpart. What this neural network does is simply receive an input, which in this case that would be the perception of which button was pressed, then modify the said input by a weight, and finally return an output based on the addition of a layer. So it sounds little complicated, so let's look at how our model would represent a button press. We are thus mapping an external event to the neural network's input layer, and we calculating an output. So this output may or may not match with the reality, but as far as now we will ignore this fact and we start writing this problem in a computer friendly way. So I will be using here JavaScripting for the coding purposes. Let's start with inputs and weights. The next step is to create a function that takes these inputs and weights and calculates an output. And as expected, if we run the above, we would get the same result as our graph or the model. The next step or upgrade to our neural network will be a way to check its own output or result against the reality of the situation. So let's first encode this particular reality into a variable as shown in the picture in order to detect a mismatch. So how much it is deviated. So we will add an error function here. So our error will be equal to the differences between the reality and the neural net output. With these two new components, we can now judge our neural network. So now we definitely know that our neural network model does not work. So this is a great work and this is what we needed, because now we can use this error to guide our learning. It all makes a little more sense if we redefine our error function as follows. So now our error will be equal to desired output minus the neural net output. So a subtle yet important difference that implies that we will be using previously observed results to match against the future performance. So this also works in real life because reality is full of repeating patterns, so it probably pays as an evolutionary strategy. Further modifying our code sample is just a matter of adding a new variable in our code to get the desired and less erroneous results. So we will be changing the weights, specifically the weights of the outcome we want. So in this video, we have learned about how a proper learning can bring desired results by changing the weights accordingly. In our next video, we will discuss in detail about the various propagation schemes of the neural networks. Please subscribe our channel and click bell icon for getting updates about the industry ready skills updation. Thank you for watching the video.